Hello, everyone, and thank you very much for tuning into the continuous delivery workshop. And this is our very first in 2025. And we have conducted, I think, three, four in the last year. And we look forward to actually initiating and building this initiative for this year as well. And I hope there are more people who are proposing and going to the workshop, CD Foundation, Slav workshop. And if you have some ideas or talk you want to give us, please go there and submit your session, submit your submission. We look forward to meeting you in the workshop. But today, what's our agenda? We are talking about fundamental of data ops. In this session, we will discuss strategies and a complete beginner roadmap for groups trying to implement their own data ops infrastructure from scratch by empowering developers, architects, decision makers to effectively leverage open source tools and frameworks for streamlined, secured, and scalable ML machine learning application deployment. And without any further delay, let's go straight to our speaker and her first appearance on the Cantonese Delivery Workshop, Lisa Cow. Lisa, over to you, and thank you very much for joining us on this session.
Thank you so much for having me, Saeem. I'm really excited to be presenting this with you all today. It's a really big topic, and I think one of the things that's really confusing is that we talk about data ops oftentimes as an extension of DevOps, but also in terms of the manifest and the philosophy and what we should be doing and what we want to do. But today we're really getting into the nitty-gritty technical detail of what maybe that looks like in practice. So I'm really happy to present and share with you all today. And so yeah, we're going to be doing questions at the end, but I'll start off with just a little bit of an introduction about myself. So a little bit about me. I'm the product manager at a company called Datastrato, and we're the creators of a metadata store called Apache Gravitino, which is a data catalog. And so data catalog and metadata is actually quite a big key piece in terms of, event trigger systems, interoperability, sharing information. And so that's kind of why my interest in data ops has been so keen. Other things that I do within the Linux Foundation in general include running the OPIA Developer Experience Working Group, as well as being part of LFAI and data outreach, and being part of the CDF in terms of their data ops initiative and helping start that, as well as an ambassador with the Continuous Delivery Foundation. I'm also a Google Women Techmakers ambassador. And out here in the Bay, I do a lot of events. So some folks might recognize me from Data for AI or other things. I like doing quite a bit of appearances. That QR code goes directly to my LinkedIn if you want to find me. But generally speaking, if you search me, I'll be around. So let's start a little bit about what is data ops and what that actually means, right? I think setting the stage here is really important. So when we think about data ops, we think about data pipelines, databases, maybe even, data sets and how we feed into machine learning applications. And I want to make a distinction here between data ops and MLOps, because when you think about MLOps, you think about model management, model deployment. How do we serve different generative AI frameworks even? And although there's a lot of crossover between the two, today we're going to be focusing mostly on the data lakehouse architecture and data infrastructure as we know it, because this is a really big part of enabling those applications to really thrive. So if you think about data pipelines, we want to automate and orchestrate data pipelines. We want to reduce the data silos, so the different data that lives in different departments and applications that make it hard to serve, and creating fault tolerance within these systems as well. So if you're a DevOps engineer, I think one thing that's really interesting to think about this perspective is, instead of a data engineer implementing data ops to make their work more production ready, how do you, as a DevOps engineer, enable somebody who's building an internal data platform to thrive? How do you bring those principles and some of the tools that you've been using that have been tried and true and maybe battle tested into this new idea of like, okay, we're now serving data internally. How do we get it to as many folks as possible? And then collaborate with data infrastructure teams and data engineering teams to bring this to life. So again, if we think about some of the distinction between DevOps and data ops, when we think about DevOps, we think about software delivery, right? We think about traditional application development and the traditional framework that we see with that. And generally speaking, between a lot of these two frameworks, you're going to see a lot of crossover. DataOps is still kind of emerging in terms of how we think about it, in terms of like even this idea of data supply chain or serving data. But generally speaking, can you configure, your database files, or can you configure your schemas in a way where you can then trace the different changes over time as you deploy and as you're managing your development database as well as your production database? How are you going to manage those? And I think in terms of just rote databases, we're pretty, familiar with, say, how we deploy something like Postgres. But if you think about something like a data lake or a data pipeline, you also have to think about the code that goes into transforming this data, the applications that are used to actually process and query this data, and the different pieces of this data that are going to be part of that. And not only that, but at scale. So really tough stuff to think about. And so when we think about all these moving pieces as well, we have to think about how we abstract on top of those layers for the data pipeline. If we look at maybe how data architecture has changed a little bit, so I've configured this talk to be a little bit more towards the DevOps engineers. I'm going to assume that maybe not everybody is caught up in terms of data engineering fundamentals. And so if we look at over time, what has changed in data architecture, initially in the 90s, we started off with really thinking about data warehousing and structured data. So you might be using something like Postgres or a traditional data warehouse in maybe even like a vendor like Oracle or something like that. And most data was pretty straightforward. You had relational databases, and the schema was very easy to understand. You maybe did some data modeling, and it was very manual to process and work on this data, right? And there was, of course, a lot of transactional data that was involved with this, but still really like manual work. And then eventually in the 2010s, and now as we're reaching like the 2020s, we're seeing a large amount of unstructured data, uh, even semi-structured data. So JSON files, images, text, and multimodal data like video and photos as well. But you're not necessarily getting rid of your relational stores. In fact, you're having to manage all of them at the same time. And this is what's resulted in this idea of like a data lake, right? Can you bring all this data together in one place so that it's easily accessible, but then, kind of serve it? And what ended up happening as we got to this place is that we ended up with something called a data swamp, where you had really messy, disgusting, out of date data that was of varying quality, and nobody knew, within the data lake what to use and what not to use, what was high quality and what wasn't, what was actually appropriate for analytics workloads and what was not. And so since then, there's been a lot of thought leadership in this space in terms of data fabric and data mesh to try and bring some order into this data like lake or swamp place. And that's where you have these ideas of really modern data architectures. We won't be going into it too much, but things like data mesh, and of course, data products and the marketplace. And really, kind of the idea here is that we had a really strict, beautiful, tight system before because the data that we were working with was very predictable. And then all of a sudden, this revolution of big data happened, and it became really hard to manage all of it. And now we're having to take a step back and think, how are we going to serve this data, not just for, batch workloads and analytics, but also for AI. And this is kind of where we're at, where we're thinking, okay, how do we do this? Because the number of tools that we use now have increased exponentially, and it's a very fast moving space. So that's why we're hitting eventually the 2030s, where we see AI architecture come into play. Even today, I think that there's a lot of movement in this space. And then in the future, where, we don't know what that might look like. And so I want to also bring up this idea of as data architecture moves forward and as we have a lot more data to work with, we also have this idea of data debt. So when we think about a data silo, we think about data that is in different departments, in different tools, in different places, and we can't access all of it. We can't share it really effectively. And so data debt is when you have all of this fractured or low quality data that happens from this emerging heterogeneity that you have within these data silos. And some other sources of data debt that you might have are when you're trying to integrate different types of data together or heterogeneous data sources. So say processing both video and images and, text at the same time. So as well as, the number of formats that you might have, you're not just dealing with a CSV file anymore. You're dealing with many different open table formats. You're dealing with different, extensions, and, vendors have their own file formats as well, right? Depending on where your data is stored. There's a lot of different tooling. So each time you adopt a tool, you might not be getting rid of the old tool, or your migration might not be perfect. So you're going to have a lot of debt that is included when you're trying to think about, adopting new tools. And each time we think about something like a new, machine learning model or a new foundational model, a new way to serve data, we're thinking about tooling switching as sort of being a driver of this. And of course, we're looking at legacy databases as well. Infrastructure moves very slowly, but the new stuff is coming quickly. How do you manage the two? And there's increased complexity as well in data architecture. There's a really great paper by Google. So if you have not been caught up on, machine learning deployment, this is a very classic paper called "The Hidden Technical Debt in Machine Learning Systems," and kind of one of the driving, forces behind something like MLOps, where your actual machine learning code and your actual model code, it actually accounts for very little of the resources that you need to actually deploy something. And so when we think about technical debt, we think about, how do we store our features? How do we process the data? How do we serve on, say, a cloud native infrastructure? How do we monitor these different machine learning applications and configure them and manage the resources and the clusters? And how do we verify the data quality? All of this is also applicable to data pipelines just as much as well. And so it's really important that as DevOps folks, we step into this picture and go, you know what, we've been managing clusters for a while. We know how to manage resources. We know how to configure things. We know how to abstract on top of all these layers, and we know how to serve. Let's help you out. Some other additional sources of debt that you might see across the stack include geodistribution. So unlike traditional software, data has a lot of legal implications when it comes to where you store data, how you use data, and things like that. And so this is an increased level of complexity that you have to deal with. And we deal with it using something called data governance. I'll get into that a lot more later. But generally speaking, there's also a difference between streaming data, which is, high velocity transactional data that you'll have, uh, or just like, real-time events, versus batch analytics that you'll use for your traditional BI and analytics reports, data that's typically at rest and something that's maybe outside of your event streams. You also have to think about the consistency between your data sources. So you have to make sure that you're eventually consistent at some point. You might have to think about your ACID compliance, and you also have to think about maybe some hybrid or multi-cloud architectures and the tooling stratification. It's not common right now, at least at this really large enterprise level, to have just one single cloud provider. You might be, operating both on-prem and on AWS, or AWS and GCP, or Azure and, AWS, depending on what, your particular setup is. Over time, this does get really messy, and you do have these cloud provided silos that you'll have as well. Of course, machine learning adds its own level of complexity in terms of how we serve this data to RAG frameworks. How do we create context for LLMs and for agents, right? And then how do we govern on top of that? This is really important, especially from a machine learning perspective. I think that we think about model performance and performance just in general, but generally speaking, the context that you're able to serve, and context is data, to these particular generative AI applications is extremely important. So some things that we have to think about when we're looking at the next generation of generative AI and how DataOps plays into that is, how do we serve context and how do we serve, you know, ways for queries to understand and pick up more information? And how do we actually synthesize information in real time so that we can get the most up-to-date answers, right? And then how do we actually improve the performance of these in a governed way? So governance is really important when we think about how do we actually create access systems for this data at these multimodal levels across all of these different tools. That's really challenging. And how do we then continuously monitor and update either the context or the metadata or all of these different systems so that we can have the best performance possible. Data ops is more than just the technical stuff, though. In fact, most of the time when data ops is spoken about, it's from an organizational level. And there's a lot of buy-in that has to happen in order to create something that works. So generally speaking, if you're going to have something at the C-suite level, you need to have advocacy as well as some sort of metadata management group. And generally speaking, I think the thing that I want to highlight the most here, and that's sort of the point of this whole webinar, is the cross-functionality of data ops. Data ops is no longer just owned by data engineering because data engineers are worried about the pipeline itself, but actually bringing DevOps back into this picture and having them own, how this data platform is served and works. So let's talk a little bit about data platforming. I've discussed kind of the journey of what data platforming has maybe looked like, but maybe not the internals. So I'm assuming that, if you've seen a data pipeline, you've probably seen something very similar to this, where you have an end-to-end pipeline where you have, your data source, and then you maybe pull from that and perform some sort of transformations to clean up that data, and you integrate it and you store it somewhere. And then, maybe an analyst comes over and then, puts it into whatever Tableau, and then they, maybe create some sort of dashboard. This is a very simplified view of what data kind of used to be. And data still operates like this in many ways. But what ended up happening was that many folks would build data pipelines and there would be many pipelines existing at one single time. And it was very hard to tell which pipelines were, still operational, which ones were failing. Even at, the ingestion level here, it's very hard to tell, whether the source system is, still working, is still porting in high quality data, things like that. And so that's kind of this big push of why we've moved into more like open format, shift left architecture. So if we also looked at maybe the difference between transactional and analytical workloads, generally speaking, you're going to have a lot of different ways to configure this. So this is the same thing as a data pipeline, but configured differently depending on how much you want to kind of shift left, right? So you're still going to have many different data sources. In this case, it's not just a single source system, but many different source systems, right? And then you're going to have to integrate it somehow. And you're either going to put it in the lakehouse where the processing is going to happen at that place, or you're going to, then serve it to some sort of consumer tool and then process there, right? So generally speaking, if we're thinking about querying and data query engines like Spark or Trino, et cetera, decoupling that away from the actual lakehouse gives you a little bit more control over where you store the data and how you process it and what kind of performance you have when you do process it. If we think about maybe where CI/CD and DevOps sits on this, there are undercurrents. So undercurrents really along these data processing stages, and if you are more interested in kind of those stages, I would look at something called medallion architecture, or like sort of that reference architecture for data engineering. But under here, you're going to have to test the quality of that data. Are there a lot of null values in this data? Is it the distribution that I want? And how you're going to deploy and actually integrate this between your developer environments and your production environments, right? Because this is really going to make a huge difference. And the discovery process of this is, how do you actually discover data that you have? Like there's a lot of silos that are going on, but in order for somebody to make that data actionable or use it, they're going to have to know that it exists. And underneath all of this, you're going to have to observe it somehow. So if we blow this up even more, and I'm gonna show a lot of different images, and they're all going to be the same thing, right? So every single thing that I've shown before has been the same thing, just in different formats. So if it's overwhelming, don't worry about it. You're still with me here. This is sort of the breakdown of the different apps and tools in terms of their general categories that you'll see in a data platform. So Ideally, you'll have a virtualized data layer where that's powered by metadata, and that's going to be able to let you access and see all of the different data that you have without actually having to physically move the data, because that's a very expensive thing to do. Underneath all of that, you're going to have different APIs, you're going to have different pipelines, you're going to have different, streaming systems or events, and you're going to have to process them as well. So that's really important that as you're building your data fabric or your data platform, that you're able to represent all of the data that you have somehow in some sort of single plane. And then your different applications are going to pull from that specific layer, and you're really going to have to, as an infrastructure team, manage who can access what, the fine-grained access control, how you're going to, do credential vending and for which applications, and if you're going to have any sort of monitoring in that layer. Of course, alongside the applications, you're going to have people who actually want to use it, and they're going to be, your analytics personnel who are going to be creating their dashboards, their BI reports, and stuff like that. Now, as an aside here, there's also this idea of data governance. So data governance includes and should be embedded in the data layer. So it depends on whether or not you're using a technical catalog or a product catalog or like something that's really more focused on business catalog. We'll get into that a little bit more later. But this idea of data lineage is tracing data from, its source system all the way to where it's being consumed. So being able to trace the transformations it's undergone. We also have metadata, and I've kind of mentioned this before already. So it's data about data, the data classification, and the data catalog. Again, same image, just kind of like remixed a little bit. So if we look at a DataOps platform, and I don't think a DataOps platform is a separate platform from a data platform. I just think that it focuses on many different things, right? So you're going to be able to have a dedicated team ideally that can really make sure that what's happening in production is separated from development and that you're able to orchestrate, monitor, and test between these layers and between all these different applications to make sure that you're ensuring the most high quality serving as possible to then enable something like generative AI, if that's something that your organization is trying to do. If we look at the different tools that are here, so this is from the Data Lake 3.0 landscape, so don't feel like you have to know everything, but each one of these things are going to have tools associated with them, both on the open source side and on the vendor-driven or proprietary side. And so this is kind of going into this idea of, again, there's a lot of different tools out there, and this is part of the complexity that DataOps has to manage. But generally speaking, I think the ones that are really worth noting are, of course, your workflow orchestration, how you do, your storage systems, your object stores, as well as, your querying. I think those are really the big ones that I would look at. And then on the left side here is where we're going to think about the data ops undercurrents that we're going to have. So metadata management is really important. How you do your observability, your security, things like that. I don't think that you should go out and buy all of these. Certainly not. I think that there's many open source tools that fit in this category, but it's hard. It's a lot of sprawl is kind of the main point of the slide. And so this is kind of the exact same thing, kind of blown out a little bit more, so I won't go into it too much. But generally speaking, you also have a lot of different table and file formats that you have to look at. And again, it's the same information, it's just re-represented. So I don't want people to freak out because they have to feel like they memorize everything. We're keeping things pretty high level here. So I also want to talk a little bit about where this is heading in terms of the actual, I would say, like architecture of things. So I mentioned a little bit about the separation of compute and storage. And one of the things that you'll see talked about a lot in data architecture these days is this idea of an open table format, especially Apache Iceberg. And the catalog, which is going to be your metadata store, is what enables a table format to interoperate with different query engines. So this could be Snowflake, this could be Spark, this could be Trino, it could be Flink. And so one of the ways that we're dealing with the complexity of, what we saw earlier is generally around this idea of, how can we decouple some of these things so that we can reduce the complexity, whatever data formats or data stores I have below hand, I can kind of create a layer on top of that abstracts adequately. So we did discuss a little bit of headless data architecture and shift left. I won't be going into this too much, but if you look at the top here, it's sort of an example of medallion architecture where you have raw data that then is going through these different stages of processing. And eventually you want to get it to gold, which is like, oh, this data is really high quality. And then when you're shifting left, you're actually bringing the compute closer to where the actual data is. And so you're hopefully going to abstract that out. I won't get into this a little bit too much, but if you're interested, this is more so in the field of like Confluent and what Cora is doing. And so let's get back into DataOps and DevOps a little bit. So if we look at DataOps, again, we're looking at the data pipelines themselves. If we look at MLOps, we're thinking about the actual model and how we're deploying and managing those, including our RAG frameworks. And then when we think about, DevOps, we think about these endpoints and the user experience, but also the application side of things. And they're kind of all bleeding together right now. SecOps is, of course, this undercurrent of all of these. But when we think about data ops and DevOps coming together, I think it makes sense when you think about an internal data platform. So really hammering in again and bringing people up to speed when it comes to data architecture. So again, this is the same information presented in a different way. Hopefully it's starting to kind of sink in a little bit and hammer in where you have many different data sources. It's going to have to be ingested or processed somehow. And so you're pulling it from the source system and then you're, actually processing it in some way. And if you look at that middle where it says raw, clean, and curated, that's kind of the medallion architecture that we're discussing, where it's like bronze, silver, gold layers of data. Because you really want to have people working with clean data. You don't want them working with raw data. And then as you're transforming it, you might be filling in some null values, you might be enriching the data in some way, you might be cleaning up some things, preparing it to then be served either through an API or directly into your data analytics workflows. And then you're going to have these undercurrents of data governance and cataloging to be able to track and trace this data and govern this data throughout each step of the way. From a CI/CD perspective, I think that it's really important that we take a step back and we think, okay, how have we traditionally done this with databases themselves? So databases, we kind of can get the version control down really quickly, especially for something like a simple relational store. We can kind of check the schema, we can check the data, we can check some of these other things really easily. And then we can kind of do release management and we can, implement something like GitOps, for instance, to kind of track and manage the state of the database itself and then deploy to production. If we look at traditional data engineering, though, we'll see a lot of these similar patterns emerging that did not actually come from the DevOps side of the house. And this is something called the write audit publish pattern. The write audit publish pattern is something that you can do with Apache Iceberg. But it's the idea of like if you have a data lake, how can you make sure that changes to the data lake are not necessarily going to like break right on task, right? You want them to be audited in some sort of way. So in this pattern, you're committing the changes to your staging branch, right? Instead of just directly to main, which we don't want. And then there's some sort of data quality check. So there's a lot of different tools out there, some innately within like the data storage tool, some like data version control and things like that will run the data quality check for you and validate that against the branch that you're working on, or at least the main branch. And then if the checks pass, you're going to then integrate the data in to your data lake, and then you're going to be able to fast forward. And, we do this thing called snapshot management, where we have different versions of the data lake that we're looking at, and we're tracking the changes in between, and then we're fast forwarding to the main branch. I would say that the main thing to keep in mind here, if you're completely new to this, is that you cannot just store different versions of the database and the data lake. It's just too much information. So you have to store things like snapshots, metadata files, delete files, so that you're able to refer back to the changes and understand where you're getting to. Because that consistency, especially as you're replicating over multiple data centers, if you have a distributed system, is extremely important, especially in like real time or fast moving analytics. Okay. So Some of the ways that we handle or work with some of these patterns is pretty straightforward. Again, I mentioned version control a little bit, so you might use Git to do this. You might use DVC, which is data version control. Uh, there's also this idea that's emerging of data contracts. So this is starting to get a little bit more widely adopted, very similar to an API contract, if you've ever used an API contract, where you're defining the schema. If at the endpoint, the schema doesn't match that you're, trying to push the changes to, uh, breaks or something like that, it's going to reject the changes. That way you're not breaking everything in production. And then you can have a lot of different protocol buffers in order to manage this. Of course, this can also be integrated with this idea of like SLAs and really helping to ensure that everything that's being pushed or changed is matching the kind of schema that we want. For monitoring and alerting, I think a lot of the traditional tools work as well. I would also add Airflow into this. And same thing with deployment and scaling. I think it's really important for us to use tried and true tools, and documentation is, of course, very important. Different strategy domains that you'll see within data ops frameworks include really around the data quality. So how can we ensure the highest data quality as it's coming in? And how can we monitor when that data quality is kind of breaking, which also goes to reliability and latency. Typically in the data engineering world, we look at data lineage, observability, and metadata collection as a way to be able to trace data. And those are all kind of forms of documentation too. I would say the one thing that tends to get sidelined a little bit more is security. I think a lot of the data catalogs now, including Apache Gravitino, also include like credential vending and things like that so that you can actually do it within that layer. And so, yeah, okay, let's talk about platform because I feel like we talked a lot about the data engineering side of things, and you're probably a little overwhelmed, which I totally get. But that's kind of the data engineer's world, is all of the things that we discussed, and that's a ton of stuff. When we think about platform, though, it actually goes quite a bit deeper. And generally speaking, when we think about platform, we think about the derivatives of really how do applications maybe serve and work on this. But we also have to think about, okay, we have data and we have it on a cloud. How do we actually manage the service around it? So how do we create microservices to actually uh, you know, help people interact with it and modularize those pieces of the platform? How do we think about the data transport, between all of these different networks that we have and the operating system itself, which tends to not get talked about at all. But your operating system and your like actual physical system is where your compute is, right? It's where the things that are going to be processing this, and they have a huge impact on the way that your data platform performs and is structured. When we think about data observability, so this is kind of going to the idea of how do we measure something like data quality. I wanted to throw this slide in because generally speaking, if you're coming in from a pure DevOps background, maybe you don't necessarily know this stuff. Generally, when you're a data engineer and you're thinking what is maybe gold standard data, you're thinking that the data is as up to date as possible, that the schema is correct, and that it's what you expect it to be. Uh, and as well, the lineage is very traceable. So you're able to trace the assets and it's very transparent where the data is coming from. And the data itself is within a distribution that you expect. So is it, if there's any data points that are higher or lower than maybe what you expect to be coming in, then it's not within a normal range. And the actual volume of the data. So as you're ingesting data from these source systems, are you having the amount of data that you would expect from that particular source system? Or are you having a lot of duplicates? Are you maybe not having as much data? So maybe if it's one row when you're expecting thousands or billions, that's a problem, right? When we think about data ops generally, I think that we do talk quite a bit about agile. So I talked a lot about data platforming just now. I'm going to kind of move forward into some of the organizational stuff that maybe is a little bit lighter to think about. So when we think about agile, we do see it like easily applicable to something like data ops. And really, I think one of the things that data engineering has missed has been the discipline of developing, software and developing data as software or with the standards of software in that sort of like incremental, continuous way. when we consider agile, really again, it's thinking about how do we iterate continuously and how do we create things that are available for other folks like analysts or maybe machine learning frameworks who want to consume that data. But with this shift, I think we really have to start thinking about data as a product. Data as a product is something that has like a guaranteed uptime, has guaranteed quality, that really thinks about how it's being served and consumed versus just okay, the data is there and it exists, and this is what you're dealing with. You can use Scrum, and you can use all of these different frameworks in order to improve really key points within your data pipelines and within your lakehouse performance. So generally speaking, you're thinking, is this data getting to the consumer quickly enough? Or is it like got a good uptime in terms of like the actual availability of the data when, maybe the lake house or some sort of component of the lake house goes down, are we actually able to get back up in time as well? And so a really good book to go over some of these things is Practical Data Ops. I would highly recommend it. It's a little bit more data science focused, but I think a lot of the principles there are very highly applicable and very great in terms of organizational focus. So I won't be going into this too much because I think that we've discussed a lot of this already, and maybe some of the folks here already know about agile. But generally speaking, if you were to apply some of these general agile principles to databases and to data lakehouses, I think that there's a really cool idea of like how can you refactor your data lake or your data pipelines in order to be more performant? How can you have continuous integration and continuous configuration? Of course, and how do you test the database? Can you do something like regression testing on these different data sets that you have? Blowing this up again, if we were to take the image that we saw in kind of the very first few slides and bring these principles in, this would be kind of the end goal that you would have for some sort of data ops and a database design, right? Are you able to, at every single step of the way, trace and continuously deploy and secure what your data is actually going through? And so I won't be going into this too much because I think that we've talked a lot about it already, but it might be a good reference for some of you folks. So now I'd like to talk about microservices a little bit because what ended up happening when you first developed a data platform was that you ended up with this monolith. That's literally what a data lake is that you're dumping all the data into one place and then you literally have this monolith and we're thinking, oh my gosh, this is so messy. If we talked to more software engineers, we could have avoided something like this. But now we're going to hit, microservices and, distributed monolith territory, which is, something that's going to be fun to deal with in the next 5 years. So when we think about data as a service, in this particular context, I'd like to think about the data processing and the different data applications that you'll have and all of those tools that we saw previously in the landscape as microservices that people can call upon or use in terms of API. Data as a service is also used to describe a data product as a service. So if I'm a company that shares data as my product, that might be a data as a service. That's not what we're talking about here. That's like an actual SaaS model. So generally speaking, when we think about microservices, we think about, moving things from client side to server side possibly, and dealing with all these different aspects, right? So if we're going to apply data ops to this, we have to think about, people requesting data instead of us just serving data and making those requests as successful as possible, right? And with that, we have to think, okay, what would a request look like? And what would an API design look like in this case? So we think about somebody, querying the data, that's a request. We think about them sending data or updating data, that's a request, and maybe changing the schema or some sort of change, and that's a request too. Also around the metadata around this. So if we're designing a service, then we have to think about, is it something that's elastic? Is it going to have resources behind it? Is it going to be fault tolerant? Do I have to think about load balancing at any single point? And right now in data architecture, there's a lot of movement towards REST. This is because there's a lot of issues with getting consistency and dealing with complications when everything's client side. And so now we're moving to server side. And I think this is a really good move. But it does mean that we actually have to provide a reliable data platform. And that's kind of where I think data ops really comes into play. With all of these services, you can have specifically defined service level agreements. And of course, This is really important in terms of how we actually visualize this in the data space. It might not necessarily be directly applicable when we think about, maybe how software is traditionally delivered, but we can also think about this idea of maybe like SBOMs or, as well as this is part of it. So again, I discussed a little bit about, monolith to microservices. Right now, data has hit monolith in the worst way, and now we're moving aggressively towards microservices. And ideally, we would like to hit modulith. This is something that software has been through already. And if you're a DevOps engineer, you've probably been through this and seen it. Data engineering is just kind of on this 5 to 10 year lag behind because we're still figuring it out. And I'm hoping that by talking with you folks a little bit more, that you're able to bring your expertise in to help us go straight to modulith, ideally. Data reliability engineering. So this is also a really big component of, how we think about microservices and data services and data platforming. And, it's pretty important in my opinion. This is really around, the actual process of being on call or the service that you might have, what kind of team you might have that's in charge of kind of keeping the uptime for a lot of this. And of course, if you're in a really large organization, you might think about some of these ideas of, what's the service strategy? How do we design this particular service and how do we operate? I'm going to focus a little bit more on the operation right now in terms of like the incidents and the requests that you might get and how that might look like. So if we look at some of the core aspects of data reliability engineering, and this isn't a book that's marketed as data reliability engineering, but I think if you're a DevOps engineer, this is probably one of the best books that you can get, just to explain to you how, if the data engineering platform is already set up, how you can bring the tooling that you have in terms of software engineering and DevOps tooling in order to elevate what they've already created. So it's called Data Engineering Best Practices. Very, very dense, very high level, deep technical book. I would not say it's for a beginner, but if you already have a platform in place, if you already have a mature stack, this is a really good place to get started in and provide value to your organization immediately, I would say. So again, when we think about the core aspects of DRE, we think about the way that we handle incident responses, especially if a pipeline fails, or how do we, resolve different issues? How are, alerts triggered? And who it sends to. Is it to an analyst? Is it to a data engineer? Who owns that and who cares, right? This is a really important aspect because not everybody who's going to care needs to know or even has the ability to fix anything. So you really have to think organizationally, where does the ownership go with this? Of course, release and change management is a really big part of this, and having your checklist. Postmortem, of course. I don't necessarily know if, traditional DevOps culture has really fully penetrated data engineering. I'd love for it to a little bit more, to be honest, in terms of blamelessness, but it is what it is. And of course, thinking about production readiness as well and how you define user groups and roles, I think is quite important. Observability is, of course, a really big part of this. So when we think about traditional data observability versus software observability, you're going to notice both this divergence and convergence of tools. And I say this because a lot of these observability frameworks that we've seen uh, typically do, like even OTel, for instance, are trying to also accept and monitor more things on the data side. So we're going to see more of the in-between tools over time, I would expect. But generally speaking, there are some differences, right? In terms of if you're looking at the pillars specifically in this chart and the root cause analysis, where you're getting the metadata and what you're actually doing to explain some of the events that you're seeing is going to come from very different places versus like just logs. You're going to have metadata and lineage that come from different pieces of the data pipeline. And that's going to have very much like different tools that exert this kind of data. So you're going to have to do a lot more manual work to piece together the root cause analysis versus like a traditional software logging tool. And so generally speaking, you're going to also have to think about where and how you think about your technologies that are stored here and where you're going to really like store this information and where it's relevant to in terms of, what's appropriate. Data pipeline management. So this is sort of in this idea of incident management and root cause analysis. So again, it's very similar to maybe stuff that you've seen already, but I'm not going to like reiterate too much. I think many people here know what a run book is and what on-call is, hopefully not too much. But generally speaking, if you're going to do a root cause analysis, again, looking at that observability tooling and the different aspects of that, you actually have to look at the data and you actually have to look at the data lineage and the metadata that's exerted through the different applications that have touched and transformed this data. That's extremely complex. And one of the things that I want to point out here is that you can't just have a dedicated data pipeline management team and kind of hope that things go well. And the reason is because a lot of the data that you see actually requires domain knowledge to know exactly what's wrong and what's right. And so there's a very specific type of cross functionality that has to occur here, depending on the data that you're actually trying to troubleshoot. Okay, to some more technical stuff in terms of, we've talked about some of the organizational stuff just now and maybe what the processes look like. Let's talk about, declarative programming and some of the very familiar tools that maybe you guys already know here with this very specific data engineering flavor. So declarative data pipelines, again, I don't have to explain YAML to this crowd, hopefully, but generally speaking, a lot of the configuration that you'll have within that leverage, say something like YAML, will have very specific tools within data engineering and data pipelines that look familiar but are not quite the same. So I think Airflow is a really good example of this, where you have directed acyclical graphs, which are, a way for us to define different workflows in a way that is non-circular. And so you're not recycling any sort of assets. And the way that you maybe write or define these DAGs or workflows is through, say some sort of configuration file. Same thing with your pipeline orchestration, or if you're using, say, something like dbt, how you're going to declare that particular data model and define, the current state and the end state that you want it to be. But there's also a lot around it. We've talked about this during the data platforming section, where that configuration is, what the credentials are, how you access it, and where you're sending these test results, things like that. So there's a lot of stuff that is worth declaring in data pipelines, but it's very hard to do because of the tooling sprawl that you see. But that's also why it's so important. Of course, you can then version control some of the stuff. Simon Spatty has this really great blog that he did for Rill. So he's a very prolific writer in the data engineering space, and he has like kind of a new book that he's sort of working on, or a collection of stuff. I would highly recommend his stuff. Very, good depth of knowledge there. And generally speaking, if you're looking at declaring or making a data stack a little bit more declarable, really you're looking at reproducing and testing and configuring all of these different things so that your deployment patterns are a little bit easier to manage, and that you're able to track changes a little bit easier, you're able to roll back. And generally speaking, if you're abstracting too much, however, then it's very hard to do your root cause analysis and to drill down, because there's so many different components to data pipelines to manage. So I think this is a really big caveat of something like this. Whereas, the more complex your, data infrastructure is, the more, I guess, elusive, or, it would be very nice to have more abstractions on top of something that's very complex. But if you abstract too much, then it's actually going to be a really big headache for you when you're trying to do your root cause analysis after, and you're trying to drill down. So of course, this is data infrastructure as code, and really managing the dependencies as well. Dependencies are a really big issue now that we're working with so many different applications within the data sphere. And of course, again, just trying to gain some visibility and traceability in the system. I won't go into this too much, but this is kind of an example of maybe what a declarative data stack might look like that Simon came out with. So generally speaking, different adapters and different connectors may have their own ability to declare, and then you can kind of, generate, or you can leverage those to generate different config files if you want to, and then serve them. And then whatever orchestration system that you're using, in this case, you might also use something like Kestra, which is also declarative. You're going to be able to help trace and manage all these different components. Okay, GitOps, I won't be getting into this too much, but you can, with enough containerization, actually implement something like GitOps for your data pipelines. It's not super popular. You'll see Git used a lot just in terms of general software engineering, but in terms of a full GitOps pattern, it is not as common as you would expect. And I think a part of this is just knowledge gap as well. But generally speaking, one of the caveats that I would say here, if you're trying to move towards a GitOps framework, is you're dealing with many stateful systems and workloads and context and dependencies with data pipelines that typically aren't super applicable in a software engineering context. And so that adds a high level of complexity. You also have to sync between the state of your data lake and your data warehouse or whatever, and the actual containers that you have. So it's really important that you keep these things in mind before you jump straight into this. Of course, you can containerize different pipeline components using something like Docker. And so by packaging these tools, you're able to create more reproducibility. Of course, I don't have to explain the benefits of Docker to something like the CDF, but generally speaking, I think Docker has started to try and shift some of its strategy to be a little bit more data friendly. They do have a very specific Docker Hub tag for generative AI, and Opia also leverages a lot of Docker containers as well to really containerize a lot of the different components that we'll see in a lot of the different services. I don't think it's quite there yet, but I think that they're making more of an effort now. So of course, we think about some of these things as being very beneficial to us. I won't go over this a little bit too much just for the sake of time and because I think I don't have to explain why containers are so great to a DevOps crowd. But you can really either containerize your entire pipeline, as you see on the bottom, or components of your pipeline. So let's say you have Airflow and you're, containerizing it with Docker, you're storing your configurations there. As you're changing different versions of Airflow or as you have multiple Airflow deployments, that makes it much easier to manage, especially at like a really large scale. Same thing with your stores. And so you really have to think about what is the best middle ground for you guys and your organization in terms of how much you want to store in your Docker container versus not, and how many configurations you want to manage. Having an entire pipeline might sound extreme, but it might be appropriate for what you guys are doing, depending on what you need. And so, of course, when we think about how maybe this works in machine learning applications as well as traditional DevOps infrastructure, you can also have entire applications within containers as well, including like RAG frameworks, for instance. And then you're going to evaluate against those. I won't get into the machine learning stuff too much for this talk, but generally speaking, I think it's a really important thing to keep in mind. Data on Kubernetes and cloud native data. So friend of mine, two friends of mine, Jeff Carpenter and Patrick McFadden, came out with this amazing book. They're both very big transactional guys. They worked on Apache Cassandra, and they came out with this book called Managing Cloud Native Data on Kubernetes. And I think it's a really great introduction to, if you're running stateful workloads on Kubernetes and if you're thinking about deploying databases on Kubernetes, why there's some complications with that and how to do it correctly. And so Kubernetes has a lot more support now compared to back in the day in terms of running databases and stateful workloads. Of course, this is something that as SREs, it's very much important to optimize. And of course, you're thinking about how to deploy and make all of these microservices that you've created from data components available and replicable in distributed systems. So I think Kubernetes is going to be a really big part of that. Data engineering on Kubernetes. So of course you can use Helm charts to define and configure and deploy your different data engineering applications and pipelines. And then you're also able to do the same thing with a lot of databases. Not all databases are deployable to Kubernetes, but some that have been really proven at scale include MySQL, Postgres, Cassandra. Some have been specifically curated just for Kubernetes deployments. So this includes TiDB and AstroDB as well. And I also want to say that there's some very dedicated orchestrators that you can use for deploying pipelines and batch workloads on Kubernetes. And one of the projects that I want to highlight in this space is actually Apache Unicorn, which is shown at the bottom there. And so if you're dealing with something like Airflow a lot, and if you're needing to then deploy in Kubernetes, Apache Unicorn is going to be a really good tool to look at. And of course, Kubernetes, tried and true, very big industry standard. And so if we can, the more that we deploy on Kubernetes, the more we can leverage other tools for observability like Prometheus and Grafana for our logging and performance monitoring. So I'm going to go through some examples now of some things that you might see deployed on Kubernetes. So generally speaking, you're going to see Spark on Kubernetes as well. And for the sake of time, I'm going to probably run through some of this before I get to the end. This is a very deep and packed talk. So it's not if you're able to stay with me at this point, I'm very impressed, generally speaking. But Spark is one of the processing engines that you'll use, especially in big data and distributed frameworks. And it can also be extended to Kubernetes. There's a couple different ways that you can deploy it on Kubernetes as well. It has a dedicated Spark operator, Kubernetes operator, and then you can also, then manage the resources and the control that you have over it. And so I think that's something that's really great, and you can then leverage, generally speaking, Kubernetes, auto scaling as well. And so a couple of different ways there. Same with Airflow. Airflow makes a lot of sense on Kubernetes as well. It has a couple of different deployment patterns that you can have. Generally speaking, you can use a Helm chart. You can have the Kubernetes executor. There's also a project called Celery, which is part of Airflow. And then that allows you to also deploy on Kubernetes. And it has some very cool features as well that are very good to leverage if you're going to be using Airflow and Kubernetes together. And so for the sake of time, I won't be going too much again into the machine learning stuff. I think that we've again gone through a lot at this point, but generally speaking, a lot of these same components that I just mentioned, specifically with Kubernetes, also apply to machine learning platforms. That's really important to keep in mind where, your control plane, how you're managing your, FinOps, how you're managing your compute and your clusters, all of these things also apply to machine learning distributed frameworks like Ray, if you're using Kubeflow or MLflow, Spark, et cetera. And so all of these things go hand in hand with data. And maybe that's a future talk, but certainly a little bit outside of our scope for today. Same thing with AI agents. So a lot of agents will probably also be deployed on Kubernetes at some point, maybe 7 years into the future, and they will probably also require some sort of state or context, which means that if we get our DataOps right now in terms of our Kubernetes strategy, then it will make whatever agents that we deploy later a little bit easier to also work on. And I'm sure there's somebody that's going to already be working on that. So yeah. Generally, though, again, this is sort of a joke slide that I put in, but a lot of the things that I mentioned right here, very declarative, very configurable, and it's very easy to fall into the rabbit hole of over abstracting. And so when we as DevOps engineers sometimes jump into something like this and we just want to throw in all of the tools that we already know, sometimes we lose sight of the actual like fine-grained domain knowledge and the things that don't work in data that, not every single application needs to be deployed on Kubernetes or containerized, and sometimes it doesn't work that way. And it's really important to keep that in mind that you have to work with those teams to understand whether or not it's appropriate to do all these things. But generally speaking, most of the resistance that you'll have is actually the other way around, where you're trying to bring all these DevOps tools into the data engineering stack. And then they'll go, I don't care. I don't see the value. I don't know it. And you'll have to kind of advocate for yourself there, which is why we have talk here. So metadata management. Okay, we talked a little bit about metadata before, way at the beginning, like around an hour ago, according to my clock, and we're bringing it back in again because the way that you enable all of these different processes is through metadata. If you're looking at a framework here, all of your DevOps tooling is going to have to work with that metadata instead of specifically the data itself. This is safe, this is good. And when we think about observability, we think about configuration, we think about all these things, it's all done in the metadata layer, especially governance. One of the things that we've seen change with metadata is that previously, when we worked with very end-to-end point systems, we didn't really have to worry about like serving all these different data silos to all these different folks. Whereas now we're thinking a lot about how do we have this common layer or fabric layer, also here listed as the common semantic layer, as a platform that we can then serve to all of these other folks, right? And this is something that I think we're very familiar with, especially in terms of data pipelining. But now we have very automated systems. We have event triggered systems. We need to orchestrate in like a very automated way. And so we're moving towards this era of active metadata and what that looks like and why it's so important to, create really clean systems and monitor these systems in order to create, microservices and applications that can serve data in an automated way. So I won't get into this too much, but if you're interested, I think that event-driven data architecture is something that's going to play a really big role in the next 5 to 10 years. And these events are going to be really important in merging the interoperability between different tools, especially if you're looking at something like, old Metagrid, type of architecture is very new. He just came out with it in January. So definitely keeping it in mind. So in terms of governance, all of the metadata that we have that's stored in the data catalog will have to power governance at some point. So this means, defining who owns the data, what are the security rights to the data, depending on your user group, what is the availability of the data and how do you access it, what is the quality of the data. All of these things are stored in metadata layer. And the way you're going to do that is through the data catalog, of course. And so the data catalog is going to be your repository of all of the metadata that's comprised and pulled from all of these different systems and tools. And so this is really stuff about defining your data assets. And if you don't have something that's end to end, it's going to be really hard. There's two types of data catalogs that we want to consider. The first is a technical catalog. So many of you might know Hive Metastore, AWS Glue, Apache Gravitino. And then there's also the business catalog, also similar to like, say, an Atlan or an Elation that you might have. And so the technical catalog is really about defining things at a very low level, which engines can access what data, and defining at like this row and basic level, the ways that you're going to have the interoperability between these tools. The business catalog is really, defining maybe the business glossary of this tool, maybe something like a data dictionary, those sort of things that are really like kind of performed by data stewards instead of data infrastructure engineers. But generally speaking, if you're looking at a technical catalog, you really have to think about your access control. So if you can have a single control plane for all of your data assets, that's really important, as well as supporting a multi-cloud strategy and virtualizing that data so you're not moving that data. If you're not moving the data, but you're still able to perform federated querying, you can keep your compliance, you can keep your GDPR compliance, you're not in any legal trouble, and you save some money while at it. So that's really important as well. An open source data catalog is a really important part of this. So if we think about the metadata and what that data fabric is, and we think about all these different compute engines, so Spark, Trino, PyTorch, and Ray, we don't really have a metadata layer that can sit on top of these open table formats. So I hinted at this, but I didn't explicitly say it. But a lot of your data lake, because there's so many different formats, is going to all kind of now be stored in an open table format, where underneath it's a little bit more agnostic to the actual file extension in the format that it is, as long as it's relational. And then as long as you have a common open table format on top of that, the engines that you're working with will kind of know what to predict. And once they kind of hit that catalog. The biggest open data catalog that we have right now that supports the most amount of tools is actually something that's quite dated, which is Hive Metastore. And Apache Gravitino is kind of the emerging new space for this in terms of breaking down these data silos and replacing Hive Metastore because it supports all of the above engines, including Flink, as well as all of the below data formats as well. So this is kind of the unified metadata management model that you'll see, where you'll have these different types of data in different places. So you'll have Kafka streams, schema registry, you'll have machine learning models, and you'll have your data lake and your data warehouses, all spread throughout different clouds, including on-prem. And so if you have a built-in catalog that can inherit or handle all of these different things, then once you're working with the engine or your Python client or your machine learning team, you can then define the access in that layer, define the policies, and do that. And that's kind of what the Apache Gravitino project is really about. This is kind of a high level overview of kind of the architecture of it. I won't get into it too much for the sake of time, but I think that really to enable all the configuration and the abstraction that we've discussed before, we kind of need a place where there's reliable metadata for all of these tools to pull and push from. And really, it's going to be something open source. I don't think it's going to be something proprietary, to be honest with you. And so if you're interested in Apache Gravitino, you can just Google it. You can also go to GitHub, Apache/Gravitino, and you can also scan this QR code. And so I just want to have some very quick last minute notes as I'm wrapping up here on these other aspects of data ops and why maybe data ops is so important. So data FinOps is really important. I think oftentimes the way that we target cost effectiveness is by the performance of either the query engine or the foundational model, depending on which part of the stack that you're concentrated on the most. But generally speaking, the more data ops that you do, the more management and fine-grained control you're going to have over your resources and over like just reducing as much redundancy as possible. And so you're actually able to save a lot more money this way. And I think this is something that, in terms of value prop for adopting something like data ops in your organization and making it a dedicated initiative, this is probably going to be the best way to get buy-in from different parts of your organization, right? Because data is very expensive. It's probably more expensive than many other things. And so you need to be able to reduce the amount of like transfer that you have over the network between different data stores, reducing the amount of data that you're actually storing by reducing the duplicates of the data that you're having to store. And you can do this through metadata, of course, and snapshots, like I mentioned. And of course, having more flexibility to move from expensive storage to cheaper storage. This is a really big part of why we're separating compute and storage, because if it's all in the same place, you have all these different pricing models that are very predatory. And I'm sure some of us have fallen victim to some of that. And of course, the data at rest versus data that's actively being processed is going to be a huge part of our cost as well. And so there's a lot of different parts of this that are included in data ops in terms of our pipeline that are a part of it. So I won't get into this too much. You're welcome to take a look at it. There's not a ton of resources around it, unfortunately. I think that an all-inclusive, like definitive resource is still something that needs to be made for data FinOps. I also want to include data SecOps as part of this as well, because the way that we secure so many of these different parts in terms of our credential vending, in terms of our roles and our security policies are really important. Apache Gravitino is great because we do path-based and SQL-based policies that you can then push down. But generally speaking, I still don't think that's enough in terms of covering your entire architecture, of course. And so the way that you think about the access patterns, it's really hard because data is one of those fields and teams that has to deal with very non-technical consumers as well as super technical consumers. And now we have to think about the ways that agents are accessing data, the way that LLMs are accessing data, and all of these different generative AI frameworks that are coming into play. So very important note to have here. If we really were to summarize everything, and oh my gosh, we're finally nearing towards the end of this really packed and stuffy presentation. So congratulations if you've made it this far. You're going to have the metadata at the center. So I'm really a big component of this, of the data catalog. That's why I work for a company that does data cataloging and why I'm pushing open source data catalogs so much, because it's the unifier between all these different things. And within your core data pipeline, you're going to have your data ops frameworks and undercurrents, and then you're going to have to secure all of that in some sort of way, right? Okay, a little bit about the Data Ops initiative. So if you liked even just a little bit of what I talked about today, I would highly recommend that you check out the Data Ops initiative, c.foundation/DataOps. This workshop is being hosted as part of the Data Ops initiative. And really, we're trying to put together more materials and tools and guides and ideally like some sort of certification or course that goes into all of this stuff more in depth and also extending it to MLOps too. For the sake of having only 1 hour, I focused on only half of what we could be covering. And even within that half, there was a ton that I skipped over, not very much in super deep depth, but enough for you to kind of hopefully get a good starting point. And this is a little bit with our roadmap as well. I also want to take some time to plug the OPIA project, which has recently been donated to CNCF. And so you're going to notice a lot more collaboration between cloud native generative AI frameworks. I think this is really important to keep the open source standard. And of course, these are some of the topics that we could be going over in even deeper quality and in depth, but we don't have time for right now. But we want to create like a really authoritative source of information and knowledge sharing for folks to come together and to be able to learn. And of course, if you want to get involved, please do, fill out our interest form, check out our community meetings. We do birds of a feather type deal sometimes and presentations. And of course, we are out giving talks and presentations and writing blog posts. So please do check us out. And thank you very much. I did go over a little bit, hopefully by not too much, but thank you for having me. And I'm happy to take any questions that some folks might have.
Thank you very much, Lisa, for a wonderful crafted and a marathon workshop on DataOps. I really enjoyed the turn. I think you covered all the nitty-gritty details, all the topics that is actually relevant to the different persona of the attendees who actually made it so far. It's good to see that 12 participants still here. As beginning you started and 17 of them are there. But we have some few questions from, I think one of my friends is actually also as attendees, Michael Cade. So one of his question is, does backup or in general, data production cross the minds of data ops?
Yeah, so if we're defining data protection in terms of privacy and like data at rest, it's a really huge part of it. So I didn't cover this, but oftentimes in that metadata layer, we're actually doing our masking and tagging of different data. And if we look at data sec ops, really storing and encrypting the data as an undercurrent is a really important part of that. So yes, it's absolutely part of data ops and it should be owned by data ops because in my opinion, if it's owned by security, it's not going to get the same amount of buy-in.
Good. Another question from the Michael Cade. I work in the data protection space and I'm hearing more and more about data classification. And you mentioned this a few times in regards to making sure you have good, clean data or understand your data. What tools are you seeing out there doing this?
Yeah, I would say data classification, we didn't cover it a ton in here, but there's a whole sector of data cataloging that really concerns itself a little bit more with a field called information science. And a lot of it pulls from library systems. So it looks at data as an ontology and creating taxonomies of data, and then you're classifying data in these really specific ways. One of the experts I would point to in this field is actually Jessica Talisman, who is at Adobe as one of their information architects, and she's fantastic, has a lot of great material around it. And so the way that you actually classify and do that data is really going to be at the organizational level for what makes sense for you in terms of how you want to define what's important privacy-wise. And then on the technical side, how you would store that information and then define policies around it is again kind of in that metadata layer.
And one final and the last question from Michael Cade. Is it fair to say that people are not rolling their own model and more likely using a public model or downloading one from Hugging Face?
Yeah, this is a really big thing right now. A lot of foundational models are being used out of the box. It's not as popular now to deploy and fine tune your own model, and it's actually seen as a really large waste of resources to build your own model from the ground up. However, using a public model and using a Hugging Face model sometimes poses a lot of security risks that we don't think about. And one of the issues is that it's not the guys that are concerned with security that are actually downloading the Hugging Face models. It's your machine learning team, right? It's R&D. And so you then have to work backwards if you're a security team and go, oh my gosh, where did you download this thing? Where did you get it from? I get that it's performant, but you need to tell me more information about this so then I can secure it better. And even, we've already given it access to all of our data. Like, what now do we do? And so this is kind of a really huge issue that we're having right now. And oftentimes what you're seeing is models as a service, right? So let's say you're looking at, GPT or Claude, you're calling the model through an API and you're trusting that on their end, they're securing the requests in some sort of way, but that's also a very specific type of vendor lock-in that you can have too. So that's kind of the common things that I'm seeing.
Thanks, Lisa, for answering those. So that's what we all have. I think, Michael, Kate, if you have any more question, do let us know in the one is there. And one more from an anonymous attendee. Is there a way yet to scan pickle files downloaded from Hugging Face, for example?
That's a good question. Personally, I haven't looked into this, and so I don't know any specific tools that would. But I do know that there are like some like security evaluators that's like regularly report and scan on Hugging Face, and there's some auditors that you can have. So I imagine that if you go down that rabbit hole, you'll probably find some more specifically for pickle files. Yeah.
Awesome, thank you. And also, Michael is one of my friend from the CNCF. So he actually also created a 90 days of DevOps repository, and he mentioning that he's starting 90 days of data ops. That best wishes for you, Michael. We'll look forward to seeing what's actually dropping for the community. Thank you much for your wonderful sports for throughout the year. And thank you very much, Lisa. Just one question for just my side. I work a lot within the CNCF on the platform working group and the platform engineering space. And thank you very much for this detailed, crafted, and precise topic on DataOps. That's not many people are talking about these crucial concepts. We are busy with what the end result the AI is giving us, and we're not talking about these very critical layer. And now people like you are jumping in and telling the companies and the foundation and everyone to be involved and stay that the things we have to be done has to be immediately sought out. Afterwards, there's a lot of challenges for the industry going forward. So within the platform engineering space, and right now that there's two things coming up. The one is AI, one is platform engineering, and one is DevOps. Like if I merge this data ops into all these layer, what should be my starting point? Because some of the companies are in one of these category, on either in AI side, either on the platform engineering side, or either on the supply chain security side.
Yeah, I would say the very basic starting point is the interoperability. One of the reasons that we don't see more collaboration in this space is because nobody knows how to ingest events from other applications that they don't know. And so, I don't know if it's, CD events has a really interesting potential to be the application that does this, but is there a common spec for events that we can have that we can then ingest? And then, even from just the data side, something like an open lineage project is trying to just do that among the data tools. And so even to go beyond that requires a large amount of adoption and, work in collaboration on all of the sides to get the metadata to a place where we can then, be able to ingest it and then we do whatever we want with it. Um, I mentioned this very briefly, but Ol Bagnosen, who is he wrote the enterprise data catalog, and so he's brought up this really interesting idea of the metadata grid. And I can't believe I'm going to propone it now. It's such a high level ephemeral type thing, but it's the idea that in your actual company, you're going to have different verticals and top-down views of your organization depending on what metadata they have access to. So the top-down view that a security team has is different from platform engineering, it's different from data because they have completely different metadata that they look at. And so if there's ways that you can link the metadata together in some sort of way, then you can have a grid where then you can break down some of these different silos. So I would poke him about it a little bit more. But I think generally that's a really, even if that's not where we end up going as a field, this idea of interoperability between teams is something that's really important. And we need a technical language to be able to do that.
Awesome. Thank you very much. Absolutely. I think the interoperability is a way is a good place to start here as well. But there's a very All of this effort has been some wonderful comments from the attendees. It says a lot of effort was put into this workshop. So thank you for your time. Thank you very much, Lisa. That's the same that's thing from my side as well. So thank you very much. I love the workshop. Usually we got bored with how this stuff long, but I really enjoyed this marathon of the kind of a workshop. The way you phrase it from the start to the end, I think it's laid a good foundation. And I think it's very important. So somebody has to step in into the industry and talking about this very crucial concept that everybody need to talk about as well. Natalia Nadtuka, not a question, but the material can be a good mid-sized book. Like I think he's asking around some book. If I'm actually understand it correctly, Natalia.
Yeah, I mean, I'd love to write a book on it if Pact or O'Reilly wants to come out with it. I think that the chapters make sense, and one of the concerns that I have, at least, is things are so fast moving. By the time a book releases, would it be relevant anymore? But I might
Yes.
think about doing like a Git book or something like that, just like well, that's what we're doing with the DataOps initiative anyway, so.
Awesome. Thank you very much. Great. I won't take much of your time. I think you need to time some relax after putting all of these energy as well. Just for the reminder, folks, you go into the CD Foundation / Data Ops, where you find this a new initiative is in the making, and you can actually join some Calendly meeting and you can be a part of this program as well. It's been some very good people are involved, so I'm expecting to have some very good research product is coming up. And also, if some of the listener is watching this offline recording or anything, and they have some topic that they want to present in this workshop, go into the CD Foundation / workshop, and you can hit up submit a proposal. Either me and Roxanne, which reach out to you, and will make sure your voices are also heard in this workshop as well. But for all that, thank you very much for tuning into this workshop. And I go back to Roxanne if she has any final things to discuss.
No, just thanks everyone and have a great evening or day.
Awesome. Thank you, Roxanne. Thank you, Lisa. Looking forward to meeting you again in another workshop. Have a wonderful day, everyone. Bye bye.
Bye.
Bye.